Hi everyone, this lesson we'll be learning about regular payments of annuities. So the goal is to calculate the regular deposit or payment of an annuity. So we have been looking at the future value and present values annuity formulas. So the future value is used to find the value at the end of an annuity after all deposits are made and interest is occurred. Let me change this to future value, because that's what we've been working with. Our formula for future value is regular payment times 1 plus I to the exponent n, all subtract 1 over our I. And just to review, present value so is used to find the money needed at the beginning of an annuity to provide regular annuity payments. So PV equals R 1 minus bracket 1 plus interest negative N all over interest. So calculating the regular payment of an annuity. So this here we're looking at R. So solving for R, we're being asked to solve for R in our questions and examples. So when we know the future or present value of an annuity, we can rearrange the formulas to isolate for R and to solve for regular payments. Remember, rearranging formula means to use bedmass backwards. So just to speed things up, when applying bedmass backwards, our formula for regular payment for future value is future value times I divided by our top bracket. Similarly, if we arranged for our present value regular payment, present value times I times our above bracket. So these are the two formulas. Sorry, let's see if you can see that there. Okay. Rearranged. So we can look at example 1. So Brienne wants to save $6,000 for a trip she plans to take in 5 years. What regular deposit should she make at the end of every 6 months in an account that earns 6% per year compounded semi-annually? So, few things. We know this is an annuity because one, it's asking for regular deposits. So we know we need our R formula. But now how to determine if we're using R from future value or present value. So let's look at what the question gives us. So she wants to save $6,000 for a trip she plans to take in 5 years. So that is not a present amount. $6,000 is a future amount, what she wants to pay for. So this is our giveaway for this to be future value. Then it also says compounded semi-annually, just to reaffirm that this is an annuity. So knowing our regular payment future value formula, we can solve. So I'm just going to write the formula here. So our R is in question, so we have to be given our future value amount, our interest, and our number of payments. So our future value is 600 because that's what we want to save for. Our interest is 6%. This is division. Semi-annually, so it's 2. We calculated that. So 6 divided by 100 divided by 2, 0.03. Okay, it's a trip that she wants to take in 5 years. So it's a 5-year savings plan. Being compounded twice a year. So we will have 10 payments, compounding payments. So if we substitute our values, 6,000 times our interest, all over again, don't do this on your calculator all at once. Follow BEDMAS. So we will simplify our numerator. 6,000 times 0.3 is 180. Then within our denominator, we can simplify our inner brackets. So 1 plus 0.03 is 1.03 to the power of 10. Subtract 1. So the top we just carry, we're working with the denominator. So 0.03 to the exponent 10, keeping 4 decimal places. Subtract 1. $180, subtract, leaves us 0.3439. Use our calculator again now. 180 divided by 0.3439 is $523.41. So these are the regular payments that she needs to make every 6 months so she can save for her $6,000 trip in 5 years. Therefore, include a therefore statement. So her regular payment deposit should be $523.41 every 6 months. So let's look at another example. So Donald borrows $1,200 from an electric store to buy a computer. He will repay the loan in equal monthly payments over 3 years starting 1 month from now. He is charged interest at 12.5% per year compounded monthly. How much is Donald's monthly payments? So let's identify what we're being asked to solve here. So we look to our question. How much is Donald's monthly payments? So we are looking for R. But now let's determine if this is future value or present value. So we know he borrows $1,200 from an electronics store. So by him borrowing the money, that is something that is happening right now in the present.